Imagine a world where, beneath the chaos of city life, there is another world, dark, silent and powerful. A hidden network of tunnels that stretch for miles under the feet of millions. This is the world of the deepest metro systems in the world. These underground cities not only power urban life, connecting people and goods, but they also defy the laws of nature, overcoming challenges that seem impossible to tackle. Today, we will uncover the engineering secrets, the historical significance, and the hidden beauty of these underground marvels that have transformed cities across the globe. Let's start in Moscow, the city that was shaped, in part, by its metro. Constructed during the 1930s, the Moscow Metro is a marvel of both engineering and political ambition. Known for its harsh winters and its complex political history, Moscow was a city under pressure. The Soviet government needed a way to transport its growing population while preparing for the worst: potential air raids, nuclear attacks, and the ever-present spectre of war. So, they decided to build a metro system so deep that it would serve both as transportation and as a fortress. The Moscow Metro's tunnels stretch as deep as 80 meters below ground, far deeper than most metro systems in the world. But this depth wasn't a result of geological necessity. It was a strategic decision. The idea was to create a system that could withstand aerial bombings and act as a shelter for Moscow's citizens in times of war. The metro was designed not only to provide efficient urban transport, but also to be a refuge, a defense against external threats. The dual purpose of the Moscow Metro, transportation and defense, meant that engineers faced extraordinary challenges. The soil beneath Moscow is made up of permafrost, making construction even more difficult. But through sheer ingenuity, engineers carved out massive tunnels and created underground stations that were not only practical, but stunningly beautiful. Now let's head to Tokyo, a city that seems to have found a way to turn its space limitations into an advantage. Tokyo's metro system had to adapt to a different kind of pressure: the lack of space. Unlike Moscow, where the challenge was to go deep, Tokyo's challenge was to create a system that could serve a city with one of the highest population densities in the world. Space is scarce, and with millions of people crammed into a small area, engineers were forced to think vertically, digging not only deeper, but also layering the stations in ways never before imagined. Unresolved. At the heart of this system is Shinjuku Station, which lies 25 meters below ground. This isn't just a transport hub, it's a city within a city. With 36 platforms and an endless flow of passengers every day, Shinjuku Station isn't merely a station, it's an underground metropolis. The challenge for engineers here wasn't only digging deep, it was about managing space, creating pathways, and ensuring efficiency in an ever-expanding city. The Tokyo Metro also had to deal with complex geological conditions, including soft soil and high seismic activity. Tokyo is located on the Pacific Ring of Fire, making it prone to earthquakes. So building tunnels that could withstand seismic shocks required cutting-edge technology and meticulous planning. Engineers had to create flexible, resilient structures capable of surviving natural disasters while continuing to function as vital parts of the city's infrastructure. Building tunnels beneath major cities is no small feat. Tunnel boring machines, or TBMs, are the unsung heroes of underground construction. These massive machines, weighing up to 1,000 tons, carve through the Earth's crust, digging tunnels wide enough for entire trains to pass through. A TBM's rotating cutter head grinds through solid rock, breaking it into manageable chunks that are transported out of the tunnel. It's a process that requires immense precision. Once the Kevin the TBM has dug through the earth. The tunnel is reinforced with massive concrete segments to prevent collapse. These segments form the tunnel's lining, creating a sturdy, lasting structure capable of withstanding the pressures of the surrounding soil and water. But the TBM doesn't just carve a path through the earth. It also helps install this tunnel lining as it moves forward, creating a continuous, self-constructing tunnel. One of the most difficult challenges faced by engineers is the water table. In cities like Moscow and Tokyo, the water table is high, and the risk of water flooding the tunnels is ever present. Engineers must install advanced drainage systems to manage this risk. Waterproof linings, massive drainage pipes, and sophisticated pumps work tirelessly to keep the tunnels dry and prevent flooding. While Moscow's metro was built for defense and efficiency, it was also built to inspire. The People's Palace, as it is often called, was designed to make commuters feel a sense of pride in their transportation system. Beautiful mosaics, marble columns, and intricate chandeliers line the walls of many stations, blending functionality with art. The Soviet government understood the importance of public spaces, places where people spend a significant portion of their time, and they made sure the metro wasn't just a place to travel, but a place to experience something extraordinary. In stations like Komsomolskaya and Mayakovskaya, the beauty of the architecture has turned everyday commuters into visitors in a palace. In contrast, Tokyo's metro system is more focused on practicality, yet it still showcases artistic vision in its design. The Shinjuku station, with its clean lines, efficient use of space, and sleek lighting, is a perfect example of how functionality and beauty can coexist. The use of lighting, signage, and design elements helps guide the millions of passengers through a maze of platforms, all while maintaining a sense of order and elegance. However, the metro systems are more than just transportation. Beneath these cities, entire underground communities have flourished, hidden from the eyes of most people, yet essential to urban life. In cities like Tokyo, New York, and Moscow, underground spaces host everything from shopping malls to office complexes. These subterranean spaces serve as critical lifelines, providing services and retail outlets for commuters and workers. Underground shopping centers, restaurants, and even entertainment venues form an integral part of the metro experience. These spaces not only cater to commuters, but help relieve the pressure on surface-level real estate, offering retail and dining options that remain hidden beneath the city's streets. The impact of these underground systems goes far beyond transportation. Moscow's metro revolutionized how people moved within the Soviet Union, and today it remains the lifeblood of the city. The metro not only connects people, it is a part of Moscow's identity. The same is true for Tokyo, where the metro system is integral to the city's ability to manage its extraordinary population density, moving people below ground while keeping the city's surface level free for other activities. In New York, the subway system has become a symbol of urban life. It's the heart of the city that never sleeps, moving millions every day, facilitating commerce, culture, and everything in between. These underground engineering marvels have transformed our cities, making them more connected, more efficient, and more resilient. But this is only the beginning. The future of urban living lies beneath the surface, in the depths of innovation, hidden from view, yet vital to everything we do. Join us as we continue to explore the secrets beneath our feet. Don't forget to hit subscribe and dive deeper with us into the hidden world of engineering.